Hello students, welcome back to my channel. Today we are covering short answer questions from chapter 3 fluidstatics. So first question we have is, why do clouds seem to be floating in the sky? So for this question our answer should be like, clouds appear to float because the density of the moist air within them is less than the density of the surrounding dry air, right? So which creates an upward buoyant force that counteracts gravity, keeping cloud float in the sky. Next question we have is, which one gives the feeling of heaviness in the case of kilogram of cotton or a kilogram of lead, and why? So for this question our answer should be like, while both have the same mass, a kilogram of lead feels heavier because it is more compact and dense, while a kilogram of cotton feels lighter because it takes up more space and is less dense. Next question. A body floats in a liquid contained in a beaker. The whole system falls under gravity. What is the value of upthrust on the body due to liquid? For a body to float in water, the weight of body should be equal to the upthrust acting on it. So when the system, body plus liquid in the beaker, is in free fall, both the body and the liquid experience identical acceleration due to gravity. There is no relative motion between the body and the liquid, and hence there is no apparent force pushing the body upward. Thus the buoyant force of thrust is zero. Next question we have is, why is the bottom of a ship made heavy? The bottom of ship is made heavy to lower its center of gravity, which increases its stability and prevents it from easily tipping over, maintaining the balance in the presence of external forces like waves and wind. Another question, the purity of gold can be tested by weighing it in air and water, and how? So for this question, by comparing the weight of gold in air and water, the density can be determined. This density can then be compared to the known density of the pure gold. So weight of the gold in air is equal to weight of the gold in water plus weight loss, and the weight loss will be equal to weight of the gold in air minus weight of gold in water. And we know that weight loss will be equal to the volume of water displaced, and we also know that density of gold is equals to mass of gold divided by volume of gold, and if the density matches, the gold is pure. If the density is lower, the gold contains impurities. Question number 6. In still air, a helium-filled balloon rises up to a certain height and then stops rising. Why? Our answer should be like, initially the buoyant force is greater than the weight of the balloon, so it rises, right? So as the balloon rises and the air density decreases, the buoyant force also decreases. And eventually, the buoyant force becomes equal to the weight of the balloon, at which point the balloon stops rising, because after this point, the balloon reaches an equilibrium and no longer accelerates upwards. Next question. In hot air ballooning, a large balloon is filled with air heated by a gas burner at the bottom. Why must the air be heated? So we know that the air is heated to reduce its density, right? Making it less dense than the surrounding cooler air, which generates the buoyant force needed for the balloon to rise. Next question. An ice cube floats in a glass of water. When the ice melts, will the water level in the glass rise, fall, or remain unchanged? Explain. So we know that when the ice cube melts, the water level in the glass remains unchanged because the volume of water created by melting ice is the same as the volume of water displaced by the floating ice. Next question we have is, what will happen to the level of water in a container when a submerged piece of ice melts completely? When a submerged piece of ice melts completely, the water level in the container remains unchanged. Why? Because the volume of water produced by the melted ice is the same as the volume of water that was displaced by the ice when it was solid. Question number 10 we have is, distinguish between density and specific gravity. So density is mass per unit volume of a substance, whereas specific gravity is the ratio of the density of a substance to the density of water at 4 degrees Celsius, which is its maximum density. Density is a physical property that quantifies how much mass is present in a given volume, whereas specific gravity is a ratio that compares the density of substance with the density of water. The unit of density is kilograms per cubic meter or gram per cubic centimeters, while specific gravity is dimensionless, meaning it has no units. Another question: if a cork is released from the bottom of a jar filled with water, what will happen and why? When a cork is released from the bottom of jar filled with water, the cork will rise to surface of the water because the buoyant force is greater than the weight of the cork. Since the cork is less dense than water, the buoyant force makes it float at the surface. Next question: a cork is floating in a water. What is the apparent weight of the cork? The apparent weight of the cork is 0 because it is floating, meaning the buoyant force equals its weight. Next question: why is it easier to lift a body in a liquid than in air? So it is easier to lift a body in a liquid due to the buoyant force exerted by the liquid, which counteracts the force of gravity. That is, the density of liquid is greater than that of air, and as off thrust depends on density, off thrust acting in water is greater than in air. Next question: what are the center of buoyancy and metacenter? So center of buoyancy is the center of displaced fluid where the buoyant force acts. Metacenter is a point that helps determine the stability of a floating object. If the metacenter is above the center of gravity, then we can say that the object is stable. Another question: state the laws of flotation. So the laws of flotation states that a floating object displaces a volume of fluid equal in weight to the object's weight. The center of gravity of floating body and the center of buoyancy are in the same vertical line. Question number 16. Lead has a greater density than iron and both are denser than water. Is the buoyant force on a lead object greater than, less than, or equal to the buoyant force on an iron object of the same volume? Explain. So we know that the buoyant force on the both lead object and the iron object will be equal because both displaces the same volume of water regardless of their different densities. Even though lead is denser than iron, this doesn't affect the buoyant force. It only affects whether the objects will float or sink. The key factor for buoyancy is the volume of displaced fluid. Another question we have is: does a ship sink more in river water or in sea water? Explain. A ship will sink more in river water because the buoyant force is lower due to the lower density of river water. In sea water, what happens is the higher density of water provides a greater buoyant force, so the ship floats higher and sinks less. Next question: steel balls sink in water but they don't sink in mercury. Why? So steel ball sinks in water because steel is denser than water, but they float in mercury because mercury is denser than steel. Another question: why does ice float in water? Ice floats in water because it is less dense than water. This happens due to the unique behavior of water molecules when they freeze that makes ice lighter for the same volume, allowing it to stay on the surface instead of sinking. Next question: a rigid, lighter than air balloon filled with helium cannot continue to rise indefinitely. Why? A helium-filled rigid balloon cannot rise indefinitely because as it goes higher, the air density decreases, thereby reducing the buoyant force. It will stop rising when the buoyant force equals its weight, reaching an altitude where it floats at equilibrium. This much for today. If you haven't subscribed to our channel yet, please hit that subscribe button and turn the notification bell so that you don't miss any updates. Till then, stay safe. Bye.